What's 35 say?
Sine x over cotan squared x minus sine x over cosine squared x.
Okay. So, we can go common denominator here. All right? But something I will say, I guess, before we start doing all that, if you see sines and cosines mixed with other functions, it's probably a good plan just to switch everything to sines and cosines. Okay? Like what else did we do that? Like, I don't think it's a great plan to do here for 31. It was a lot easier to do without doing it. But there's no sines and cosines in there, right? Okay? But if you have sines and cosines mixed with other things, I'd probably switch everything over. And that's not too hard to do, because remember cotan is cosine over sine, right? But look how this works. All that does for me is so again, you can rewrite cotan as cosine over sine, like putting sine down here, but that just creates a complex fraction. As long as it's all multiplication and division, dividing by sine on the bottom just puts a sine squared up top. Make sense? Another way of thinking about that is what happens to the cotangent if I move it up top? It becomes a what? A tangent, and tangent is sine over cosine, which is what we have. Okay? So then we've got minus sine over cosine squared, and what luck, we have a common denominator already. Yes?
How come when you did, like, you have, like, cotangent square of x, how come you have to put the square on one top and then on it?
Because cotan means cosine over sine, right? So there's cosine over sine and then another cosine over sine, so there's two of everything. So it's not just one thing squared, it's both of them squared. Okay? Yes?
Why would you combine the sine and the sine squared?
Oh, you would. I just left it out so people could see what's going on. So the maybe's right. This is going to be sine cubed of x minus sine of x over cosine squared x. Everybody with me here? We okay? Now look, let's say we're stuck. I don't know what to do at this point. What can I do? We could factor something out of the top. Let's see what that does. That leaves me there's an x on here. That leaves me with sine squared x minus 1 over, okay? And now, sine squared x minus 1 should look familiar. Okay, well it doesn't equal cosine squared. Yeah, remember? But this is our rule. 1 minus sine squared equals cosine. So if you reverse that sign, not the sine sin, but sine sign, positive negative, right? It becomes negative cosine squared. So if 1 minus sine squared is cosine squared, then if you subtract the other direction, you just get the negative of that. All that is saying, I see some worried looks. If you do 3 minus 1 and get 2, then if you switch them and do 1 minus 3, you should get negative 2. If x minus y is 10, what's y minus x? Negative 10. Okay? So this becomes negative sine of x cosine squared of x over cosine squared. I just moved the negative from the cosine all the way up front because it's all multiplication. Just slide it all the way to the front. The cosine squareds cancel, and we're left with negative sine of x. Yep. All right.